My name's Will. I work for a small company. Called Lon Labs. We're based between New York, Berlin, and New Orleans. And I wanted to give a talk today a bit about augmented reality and computer vision. Wasn't really sure the best way to tie this all up. So I thought maybe the best way would be, I guess, in the context of an app. So I'm going to show you how to put together an augmented reality football app. I threw this together with my partner in a weekend, just to give an idea of the scope. And yeah, also hopefully after this talk you realize it's not so difficult to get started with augmented reality on iPhone. Has anyone here ever made an AR app? Yeah, cool. Or anyone worked with computer vision, machine learning? All right, cool. It's a lot more people than I expected. So I'm going to move through a lot of material pretty fast. So I guess if you guys see something that obviously a hand wave over isn't clear, like feel free to stop me. Or if anyone has any questions, just feel free to interrupt. So the app that I'm going to show you quickly how to build is basically this. That's a real foot on a real floor with virtual balls. Again, it's easier to do this than you think. And I know from talking to iOS developers in the past about augmented reality, I usually get this funny feedback. Everyone just assumes, oh, Google Glass, why would we work on that? And yeah, I guess maybe that didn't really succeed. And it's like first entrance to the consumer market. Yeah, Pokemon Go, which was relatively successful. And I think AR was definitely a bit overhyped in the last couple of years. And yeah, as evidenced by it resting nicely in the trough of disillusionment. So I'm sure everyone's tired of hearing about AR. But despite the hard landing in the consumer market with Google Glass, it did kind of find its niche and industry. Also, HoloLens and from Microsoft and Magic Leap's released their headsets. So my personal opinion, I don't think that stuff's gonna hit the consumer market or get good adoption, but or at least in this iteration. But yeah, there's obviously several players out there trying to enter this space. Also, AR is popping up a bit more in context that maybe you wouldn't expect, like in car windshields or bathroom mirrors. So I definitely don't think it's going away. And yeah, like you see now with ARKit on the phone, you can develop AR apps for iPhone or iPad. So I guess another key point in this talk is that AR starts to get interesting when you throw a little bit of computer vision in the mix. And here are a few examples. This is an app called Magic Sudoku. It's on the store. Basically lets you cheat at Sudoku. Or if you're terrible at golf, this will tell you where to putt it. This is one project we did. Basically, if you're debating about whose ball is closer, this will tell you. This was demoed at WWDC, actually. It's pretty cool. That's also the body pose tracking. You can work on things like form. So another project we did for a client, things like if you want to get schematics for a car for repair, some other random stuff. I guess if you can make a lightsaber, why wouldn't you? Currency conversions, cool example, could be useful. And something I don't know if you noticed about some of these cases, they're all, or not all, but some of them are kind of transient use cases, like this currency example, or like scoring a bocce game. So you don't necessarily have to have a device or glasses. You don't have to have a device strapped to your face. These are things where you take out your pocket and do a quick glance, and yeah, it fulfills the use case. So yeah, there's a lot of tools to build this stuff. I guess since iOS 11, Apple introduced ARKit. So it definitely makes it a lot easier to do this. Before you'd use third-party SDKs, most time involving tracking, tracking codes and stuff that you have to lay around the scene. But yeah, now it's all bundled into OS. yeah, also I'll show you a bit about SceneKit, how easy it is to draw stuff with that, and how I use CoreML to do the foot detection. So real quick with ARKit, in case you're not familiar with what it does, there's a few things that are super useful, like we can track the position of the phone in space, or position orientation, so you can start to like kind of map out a scene around the phone. You can, like you see in this video, the sort of stuff you can map in a scene are like planes, like surfaces, like horizontal or vertical. So you can get kind of an idea of like the bigger space. What you can't do is map things like that vase that's sitting on the table. You probably see the planes cutting right through it. I'm sure that'll come in ARKit 3, or yeah, I mean, I don't know, I don't work for Apple, but I would expect to see that in the next iteration. Very important feature, get metric scale, meaning that if we have a model of something and we want to place in the world, it'll appear in the exact scale that we want it to be. So you can place real objects, or you can place objects in the world, and they'll size-wise be fit. Also, you can measure distances in the world. And another important factor is, or thing that ARKit provides is light estimation. So when we do place things into a world, we can apply lighting to them so they look like they belong there, not just like someone chucked a cartoony thing in the middle of a kitchen. So ARKit gives us the scene mapping, basic scene mapping. SceneKit, I don't know if you ever worked with it, doesn't have to be in ARKit context, but makes 3D graphics programming pretty easy. Like see here, I'm just throwing in a sphere, dragging a texture onto it, and then just clicking on some stuff to apply some physics, and hit play. There you go, ball with gravity. Pretty cool, no code, just mashed on a bunch of buttons. Something that vaguely resembles a soccer app. So yeah, there's actually a lot of cool, powerful stuff that comes with SceneKit. So you have access to 3D graphics API that makes it a lot easier to draw stuff. There's nice primitives. You can drag and drop in this GUI, and there's a physics engine that is able to enable just with a click, or encode this also simple. There's lots of nice model loaders. If you want to bring in assets, maybe a 3D artist developed in Maya or Blender. So okay, so back to the soccer app. So we have balls in a scene with a floor. We want to be able to kick them. So we talked about how ARKit can help map the scene, determine where the floor is. You can use SceneKit to add the balls to the scene. But at the moment, the only mode of interaction we would have is tapping on the screen to move things. But this would not, this isn't what we want. We want to be able to kick it with the foot. So we need to be able to detect where the foot is in more or less real time. So how do we do that? CoreML, yeah, I don't know, CoreML. So CoreML provides a nice way to bring in external models to the phone. iOS does come with some nice stuff out of the box in the vision framework. If you have common tasks like detecting a barcode or a face or a rectangle, but if you have some specific requirement like a foot, that's something we have to build on our own, or like find one that we can import into the app. So and the type of models you can bring in, it's not just limited to neural networks. We can also do decision trees, systems, and just other arbitrary architectures. So with CoreML, if we're going to bring in a custom model into the app, I guess there's a few steps we have to do to prepare it. We need to choose a model, prepare a data set for it, and train that model, and then actually get ready for deployment on the device. So choosing a model. So we know we need to detect the foot, but not sure exactly how. So what are the options? There are some common computer vision tasks where you can find models available online. The first one, the top left, classification. This basically, we can feed an image into this model, and it'll give us a label on the output. Say if something's in the image, for instance, above, you give it this image, you get bottle cup cube. So in the context of the soccer app, you could potentially apply this, get a label of like kicking or not kicking, which could tell us, when you're actually when you're kicking the ball, but we wouldn't really have any information on trajectory or position of the foot. So the next one, object detection. With this one, we can get a bounding box around whatever the object is. So like you see cube, cup, bottle, there's a box, and we know that somewhere inside that box is a cup or cube. So we could potentially do this with the foot, either around the whole leg, or the toe, or the foot. Another even finer approach, we could use semantic segmentation, where we get a label for each pixel in the frame. And so with this, we could get maybe finer contours of the foot, maybe develop a better model of how it's colliding with the ball. Another possibility would be instance segmentation, very similar to semantic segmentation, except we track the individual instances. For this case, it's not really necessary since there's only going to be one foot on the screen. But if you had an application where like the home shot app or the home court app where you had the basketball app that I showed you originally, where you had multiple people in the scene and one person shooting the ball, and you want to track separately, the person shooting the ball versus like the observer. For this problem, something like instance segmentation would make sense. So the approach that we chose was semantic segmentation. It's not the only way you could do it, just one that we picked. So with this, we decided to get a pixel mask of the toes. And then using this, we could place a physics body and the scene kit. And then scene kit can handle the collision with the ball, and then then you have a system that looks like actual football game. So there's some other stuff to consider when you're picking a model like this to run on the phone. Since this is a real-time application, we want to try to get the detection time, prediction time, to have that very small so that we could actually sample regularly, enough time that you have to react. So it's not like you go to kick, we detect the foot, and then the latency is so high that your foot's in a different position at that time. It doesn't feel like a real kick. Also, the accuracy in this case could be like, all right, it doesn't have to be perfect because it can more or less infer where the foot is if this mask is okay. And another thing, especially in mobile space, it's important is considering resource constraints. What the GPU capabilities are, the size of the model, how much memory you have. And especially if you're doing something like world tracking ARKit, also have to consider that you're sharing resources with ARKit. So for this particular example, it chose this network called Mobile UNet. It's put together by, I just found on GitHub. I have the links to this like in the notes that I'll publish. But it was made by someone named Kira Sosa, and this is basically designed for segmentation. It's a neural network. The original network was designed for biomedical applications, but it's been applied in just tons of places for image segmentation. And what's special about this one that he did is he optimized it for mobile. It's implemented in Keras. If you've heard of that, it's I guess framework for making machine learning apps. You can put like TensorFlow, which is a Google project, as a backend to this, and it gives you a nice interface. If you go to the GitHub repo for this project or look at his Medium post where he describes the some of the design decisions that went into making this network. You'll see he gives these examples of the performance, where you have, this is like an input image. That's the ground truth. So in this case, he's detecting the hair in a portrait. And so that's the ground truth. And then this is the prediction. So you can see it's not perfect. You got that strand off to the top left. It's not perfect, but probably good enough for our case. So we took this, but couldn't use it in its existing form with the weights that you trained for it because it was made for hair. But we need it to work on feet or toes. And so for that, we need a foot data set, basically a bunch of images that look like this, an image and a corresponding mask that shows what the network should be segmenting. And this is kind of a cool thing about neural nets is, I guess you don't have, well, first of all, there's a lot of them available online that you can try out that are designed for these common tasks. And you can just throw a ton of training data at it and then measure the performance without having to like actually do any, I guess, underlying architecting of the network itself. You can sort of just like blindly try these things out. But yeah, of course, like when people publish papers with these, they include performance benchmarks, and then if you follow people working in this field, you'll see them applying it to different applications. Maybe you find something that's similar. So if you need to get some feet, where do you go? Or I guess for any problem, this is useful to know. There are a lot of public data sets available online. Open Images Dataset is an initiative from Google. They just started a couple of years ago, but you can find labeled data here. So you can see like people breaking down the scene, like guitar, drums. So with this, you probably noticed, but this just provides bounding boxes. For segmentation, we need segmentation masks. So this wouldn't work for our particular case. Another thing is, if you search for feet, you probably notice the perspective of the feet is not the perspective you would have with a game if you're looking at your foot. These are sort of third-person perspectives. So don't find anything through with a quick search there. Other options, there are companies that will label data for you. I don't know this company. I just saw their Y Combinator startup. But yeah, basically you can send them your pictures, your images, and then they'll have a human actually label them. Since there's a human in the loop, there's a little bit of latency, and you probably see also because there's a human in the loop, the costs are a bit high. But if you don't want to have someone label it, you could just do it yourself in Photoshop. But I guess, yeah, one thing I didn't mention, when you build up a data set to train these sorts of networks, it depends on the architecture of the network, but you generally need something like on the order of 1,000 or 10,000 images for these things. So this approach wouldn't really be feasible unless you were really good with Photoshop. So another approach, the one that we actually use to train this, is by synthesizing data. This is cool. It's quick and easy and worked pretty well for this case. But basically, in SceneKit, we made a 3D model of what we'd expect. So there's a floor and a leg. And then basically randomly change the position of this leg and texture it. And we randomly change the position of the floor and textures there, and then render the output of this as like 2D images with corresponding masks. The nice thing about doing it this way is, since we know the ground truth of the foot in 3D space, we also know where the mask is. It's important to have random shit in there for a neural network. There's the thing that you're trying to detect, but there's also the background that's really important. If you're just doing it on backgrounds that don't have much texture, then the network might be more biased towards this. And if you try this game out on a tiled floor, it would not work. But yeah, like I said, this was kind of a weekend hack project, so that's why this renderer looks a bit janky. But this is like an example of a project we're working on for a client where we had to build a network to estimate pose of a vehicle. And so with this, we had a bit more photorealistic cars and scenes. Probably noticed this is Unity and not SceneKit. Okay, so where are we? So we chose a model, prepared a data set, have a ton of pictures of feet. Now we have to train it before it's ready to go. So this has improved a lot in the last few years. It used to be the case that if you want to train a neural network, you either had to have a GPU around somewhere in your office or your house, or you had to rent server time. But in the last couple of years, there's been some companies like Floyd Hub. Google started this collab project that's pretty cool. You can, I don't know if anyone's familiar with Jupyter Notebooks, or it's basically, it's a nice way to like code in a browser, I guess, using Python. But that's how this works. Basically, you have all this code in a browser, connects to Google's cloud runtime, which is backed by GPUs, or they also have these like application-specific circuits that they built, like especially for training neural nets, called tensor processing units, and that's pretty cool. Like you can train things really fast, so you don't have to, you don't have to set up a server. You don't have to have crazy hardware. You can just go to a browser and like drop in all your Keras or TensorFlow code, and then your data set, and then get output. And at the moment, I think Google offers this for, you can get like a K80 GPU for 12 hours for free. So it's pretty cheap, or even free. So so after you train the model on something like Colab, you'll get a bunch of weights out in some file format with like H5. But there's one final step to get going on the phone. We have to actually deploy it to the phone in a format that's understandable by CoreML. Apple has CoreML tools that aid in this, and as long as your network has kind of a normal architecture, it should work fine. But I guess some hiccups could be like, if someone developed like a custom operation or some non-standard architecture, you might have to like actually write some Python code to translate that. But for most normal things, CoreML tools will work fine out of the box. So you take the trained model, run it to CoreML tools, deploy a model, then we can use it to detect the position of the foot, where the mask is, and kind of use that to cheaply estimate the pose of the toe, and then let SceneKit do the rest. And so this is the result. Sorry. So what's next for AR? So algorithms are improving all the time. And if you try to follow any of these subjects on like archive.org, there's so many papers coming out, it's just difficult to sift through the information. But there's definitely no shortage of people working on a lot of these really interesting problems. And it's interesting to see like the time between like, when the theoretical model is developed in like, practical and like a server context, to like how long it takes for that to actually get to a mobile phone. Just with like optimizing algorithms, and then like application-specific hardware coming out that enables that. Like for instance, like Apple's new neural processors that they're shipping on phones. Like I think I read like the speed up from iPhone X to XS is like, it's like 10x for like prediction with neural nets. So it's really crazy. Algorithms are getting better, hardware is getting better. Consumers are starting to get a bit more exposure to AR. Things like puking rainbows and measuring tapes. Also, a lot of companies are pushing authoring tools a bit harder now, like Adobe's Project Arrow lets you author augmented reality content. Also, Facebook and Snapchat, they have filter or like lens editing tools, so you can, a normal person can develop a custom lens through a web browser. And so hopefully as now that, so hopefully the authoring tools will allow people to make more content, which will then, maybe suss out some consumer apps that perhaps weren't entirely obvious to begin with or have their own niches, and who knows, maybe this will help a bit with adoption. So I don't know if it came across that way, but I was hoping to show you that it's actually not that hard to do this stuff. Apple provides all the tools, or most of the tools. The AR is definitely not going away. So I guess most AR apps have not been made yet. Something to consider about this space. And also, at the moment, especially the ARKit, this only works on iPhone and tablet or iPad. But I guess think like 5-10 years out where things are going. You see all the companies trying to enter the market now with head-mounted displays. I don't know if that's ultimately going to be the best way or the way that AR kind of gets mass adoption in the consumer market. But there will be something because there are useful use cases for this. But just think beyond now. And then also, most of the application, or I guess all the applications that I showed here were visual. But also consider the case you can have purely auditory applications, especially things like earpods now, where you have Siri, this may be location or context aware. Also haptics, being able to touch things. Think beyond visual stuff as well. That's all I had. Thanks for listening to that rant. Does anyone have any questions?